Okay, let us process using QBrain, where you have an MRI series of the brain and you have the tomographic images as well as the CT images. So this time we will select MR series, late and early tomography. We will exclude CT because CT MRI is a better image than CT. So just let's start. This is the reconstruction stage. If you observe any motion, then you have the MDC option is here, motion detection and correction. You just select and click auto. And select the corrected series. Similarly, for the second data set, that is the late, click corrected. Click proceed. Now you can see the software will automatically register MRI with the SPECT. So if you want to see the registration quality, you can come here and select the different way of, like for example merge. So you can see the registration. So other option is with the contours. So you can see that the early image is perfectly matched with the MRI. So here what is happening, the early tomographic image is getting auto registered with the MRI. So next step is click full. Now here what it did, it is re-registering the early with the late image. Early tomographic image is matched with the, so ictal and interictal both are registered.
Okay.
Correct?
With the MRI data.
With the MRI data. So MRI registered with early, early registered with late. So that means the early image is registered with late and both are registered with EMR. Now it is doing the rigid registration of ictal and interictal. Why we need a rigid pixel to pixel registration? So that we can do the subtraction of ictal to interictal. So wait for its completion. Okay. So this one is late and registered with MRI. Just accept it. Now this one you can see it is a early image and the quantitative data. If you want to see in different colors, you can change it. And this is the drop down box where you can select different types of images, that is late uptake and second is early image. So this one is the early image and this one is the late image. Now if you want to subtract these two images, that is the delta image, that is late minus early image. So if you click here, you can get the subtracted images, right? So this to get this image only, we need to register ictal with interictal pixel to pixel matching, right? So delta image will provide what info? It will provide you the subtracted image so that you can detect easily where are the focal areas. So these are the high uptake focal areas in this, right? You can see more uptake here compared to this slice. So that is subtracted image, that's why it is showing here.
And what is the corresponding numerical value for this?
So you have the VOI option here. Once you click here, then different cortical ROIs will display here, right? So these cortical ROIs are labeled tabulated here. So if you click here, the image will highlight which area it is. If you click here, that area will highlight. If you double click, it will be remain shaded only. Double click, right? So what this table is showing, it is showing the major cortical areas where you have to detect the cortical defects. So in the table it is showing the early uptake ratios for this is the average. For example, this is the ROI, right? So it is showing the average value of SUV ratio. It is not the SUV, it is not the uptake, it is the uptake ratio. Ratio means the average of the average SUV or average uptake divide by ये पॉन्स का वैल्यू. जैसे इधर पॉन्स सिलेक्ट किया, अगर ग्लोबल सिलेक्ट करोगे तो इट विल नॉर्मलाइज विद द ग्लोबल एक्टिविटी. So see how nicely this subtraction is done. You can see directly the hyper areas. So these are the hyper areas, correct, after normal. So this is the late, that is the second study. Early, that is the first study, uptake ratios, and this one is the difference in the uptake ratio. यहाँ पे अगर आपको कंपैरिजन करेंगे, कंपैरिजन में this one is comparison, this is late, this one is early, and compare. Okay, so if you select late or early, you can see the corresponding G score or Z score, right? So negative Z score is showing the less uptake and positive Z score is showing the high uptake. So depending upon what area, what the reference region is, these values will change. Okay. Now if you want to see the MRI fused images, you can click on this different layouts to display images in different formats. This one is the 3D image. In the 3D image, how to read it? So this image is, top one is the early and this one is the late, early and late. So this is the late image. What is the difference here? This is the color scale, you can switch it on. So in the color scale you can see here the red is good, that means the red areas here are the good uptake areas, but this blue is on the lower side, so that means blue is bad. So here you can see more blue, here you can see little bit less, right? Here you can see more, here less. So early image is showing more this metabolic defect compared to the late image. So there must be given some interventional drug and do the right. Even the hemisphere, right hemisphere, that is showing overall less uptake compared to less hemisphere. And you have a NDB option here. If you click NDB normal database, you can see the factory provided 18 patients are there, 18 cases are there for creating the normal database. So this study getting compared with the normal. So these are the normal database values. This is the patient normal values. Now for example, this is 0.84, that is less compared to normal. That means it is hypo area, right? and then it is calculating the difference, negative value, negative difference or the negative Z score is saying that there is a, in this area there is a less uptake. Positive value is showing ज़्यादा uptake. You can create your own database. For example, for Indian population, uh, if you want to create a normal brain studies and you want to compare your patient scans with your normal databases, so you can just create a database here. So what you have to do, just process it and click as a new database, then you will see a new database here. Got it? That's all. Thank you.